Hello everyone, welcome to student.com. In the last class I have discussed the determination of equivalent conductivity of strong electrolyte through an experimental procedure, but that method was unable to determine the equivalent conductivity of weak electrolytes. Of course, there is another method exists to determine the equivalent conductivity of strong electrolyte, that is graphical method. During the graphical method, we have to take the equivalent conductivity on y-axis and concentration on x-axis. Based on the equivalent conductivity value at different concentration, we got the line with a negative slope like this. If you extend the line towards y-axis, it cuts the y-axis at certain point. That point itself represents the equivalent conductivity of respect to strong electrolyte at infinite dilution. But the graphical method, it was not unable to determine the equivalent conductivity of weak electrolyte because the line is almost parallel to the y-axis. So even if you wanted to extend the line, but it was unable to cut the y-axis. Therefore, the graphical method was unable to determine the equivalent conductivity of a weak electrolytes. And if you consider the experimental procedure also, it was unable to determine the equivalent conductivity of weak electrolytes because it shows the conductivity almost equal to 0. But it has certain equivalent conductivity. Therefore, both the experimental procedure as well as the graphical method was fails to explain the equivalent conductivity at infinite dilution of weak electrolyte. But according to Kohlrausch law, he stated that the equivalent conductivity of a weak electrolyte is equal to the sum of the equivalent conductivity of individual ions present in the solution. If you consider the weight of the human, the weight includes the each and every organ as well as bone. Similarly, if you consider the equivalent conductivity of an electrolyte is equal to the sum of the equivalent conductivity of individual ions, based on which he took the simple solutions like sodium acetate, hydrochloric acid as well as sodium chloride. Those three solutions are strong electrolytes. With the help of a few pages of the strong electrolytes, we can determine the equivalent conductivity of a weak electrolyte like acetic acid. So based on that, he was able to determine the equivalent conductivity of weak electrolyte like this. During the procedure, he took the equivalent conductivity of strong electrolytes. Those electrolyte ions should contain the ions which are associated with the weak electrolyte. If you consider acetic acid, we have acetate ion as well as H+. So he took the strong electrolyte which involves the acetate as well as H+. That's why he took sodium acetate as well as hydrochloric acid. In order to cancel out those equivalent conductivity at infinite dilution of those ions, he subtracted the equivalent conductivity of sodium chloride electrolyte. So based on this, he was able to determine the equivalent conductivity of acetic acid at infinite dilution. Hope it was helpful to you. Thank you. Please subscribe student.com.